Welcome everyone to another breaking news edition of our low-level IT security and other fun with code YouTube channel here. The other day an email scrolled by here, Linux kernel and other security and stuff research from Tavis Omandi from Google Project Zero and other amazing such research that caught my attention. Also we could actually focus. So much so. That is AMD Ryzen major CPU microcode bug, but not that much clickbait, already partially fixed in some microcode, but nonetheless the details are scary and it's not yet fixed for everyone and maybe probably most likely not even for you. So probably want to share, like, subscribe and watch this edition. So what I found this time, and also my previous video, right, I'm already not the greatest fan of x86 complex instruction set architecture, previous videos, contrast to reduced instruction set computing. What is the issue here? The issue is he wrote some test case for that. I have no idea how he found it even. Super, as usual, of course, the details are, the devil is in the details and complexity and stuff. So he wrote some very specific assembly program using the AVX of Advanced Vector Extension Registers, so YMM registers, very low level stuff. You probably want to watch my previous videos, right? I can't explain all the details of x86 and CPU complexity, but so these are special registers. In other processors you would have had more normal regular registers, but so this is not the general purpose, not the floating point, but the extended floating point for extended advanced vector math of all the complex x86 extensions of extensions of extensions. And as so often, the bugs in the details. And so using these registers here, so here's your one assembly program to reproduce this specifically. Loading here secrets, so secret here being somewhere defined as data section. Secret here, just secret, just some text in there to load that, and then doing some syscall, so loading the AVX register with a Linux system call number for schedule yield, do the system call, old-fashioned system call here, and then the value of YMM0 should be lost here. And so not related, it's not related to the VPX or because he XORs it, right? He XORs this YMM0 register with itself. And so if they do the ucom ISS instruction that triggers the bug, the value of M32 must somehow be below 80,000 hex as far as they found there, and only ever change the condition flags, but dump the value. So then it will revert back to the pre-XOR secret value, right? So they load here the secret value, they do a system call, they zero it after the system call, and when they then, let's take a look at the code, because the explanation, so here is load that, yield, XOR, yield again, ucom ISS or ucom miss, complex x86 system calls, system call, and then write that. So yeah, and then they always write that. So so the expected computation of this program should be zeros, like not ASCII 0, but literally zeros of this zeroed AVX register. So, and if we run this, of course I have a Ryzen, do we even, alright, actually should do that so that you see that better. Whatever. So right, and so you don't see something because hex dump, so this is writing zeros, right? Because that is full. So anyway, so it works as expected, right? We run this. And yeah, so but now he says if you run another task that is system call heavy and stuff and pin that. So we need to pin that to the same core or thread, because otherwise if you run this on another core, you don't leak that. So again, we just run this. Of course, it's not a thing, but so he also has a hammer program that does nothing but call system calls get yield here. So let's do that. And again, we need to pin that to the same thread. So let's hammer that and then, oops, yeah. And so I have to say, so he wrote there Zen 2, but so that is even Zen 3. And so the problem is, so yeah, so that's leaking some stuff, that's leaking information from one computational, it's like, yeah, who knows what other crazy stuff you can leak back and forth. So as it, not the biggest, like not spectrum meltdown and not immediately stealing your secrets, but you never know what bugs are in there. I mostly make this shout out. So yeah, bugs are bad, and it's not the end of the world. Also because also people replied to Zen. So what is the outcome? Yeah, it's already fixed for some people in microcode. So sounds suspiciously like some errata. Also there, 2023 or actually 2022. It's like, yeah, CPUs, processors so complex that not only x86, Intel, and AMD, but ARM, probably even RISC-V and stuff. Everything is full of bugs and erratas. And the problem is this stuff is not discussed enough about this, which is also why I make this video, because I was not aware of that errata. It's like who is reading even all the disclosed or non-disclosed erratas of Intel, AMD, not even like VR probably nearly never has disclosed erratas. I'm still waiting actually. There is RISC-V, Sci-Fi, Hi-Fi from a previous video, unmatched RISC-V board. There is some errata, hardware errata stuff that is not public there. I even as board owner and tiny little Linux distribution guy and YouTuber and stuff, I requested that over a year ago. I still did not get a response from Sci-Fi, Hi-Fi for the whatever 740 hardware errata thing. But so coming back to the stuff, then it says, yeah, okay, nothing too much to see here. It's already fixed the microcode. So the only problem is, there are two problems also. First of all, most people don't get this microcode. So if you like, yeah, go ahead, leave in the comments below if you have an Zen. Also, they write here Zen 2, so they have run this on a Threadripper Pro. And so yeah, for me, I just took the next base system here from which I'm live streaming, and yeah, for me that is also happening on. Can I also? What's my keyboard? Ryzen 15 or 50X. Actually, I probably should check if it also happens on 1750X. Anyway, so that is Zen 3, so certainly more is affected. And I already know from other people in some security cycles already responded like, hey, this bug is also occurring on my embedded board of AMD, whatever, Ryzen E, embedded SKU or something. Wouldn't surprise me if it also, I need to check on the Steam Deck. I only have the Steam Deck at home for obvious gaming reasons. And so for some or many of those embedded CPUs, you don't get this public microcode, right? So if you go here, I mean, the microcode stuff here is not as plentiful, right? So if you have some Steam Deck maybe or other embedded SKU stuff, you might not get the microcode easily or not at all. The other thing is, you have seen my struggle with the complexity and broken BIOSes. So I would normally not even want to flash some new BIOS. I mean, yeah, there is some microcode in the Linux firmware, but the normal way, often you get microcode sometimes with the BIOS update. And given like all professional people don't even often touch their BIOS because all my previous videos, they break so often and only constant change and regressions. And due to that, you might not even want to update your BIOS, right? And then you want to use this microcode updates. And the problem is, the Linux kernel people also deprecated the init-based microcode loading or other such stuff. So now I made a previous video, maybe somewhere a year ago, maybe on my More Life channel, probably there. And so even I currently don't run this microcode update. I actually made preparations in our Linux distribution to ship microcode updates by default. But the problem is with a very strange way, the Linux kernel people, where did I even, you know what, this is why is this, because it is not, this is another Tmax. So this is also this design decisions that I find really, really strange, questionable and bizarre, because to my extreme surprise, the Linux kernel people want this microcode early in the initRD, so you need for this to work, and I mean I implemented that, the only problem is it causes other problems and regressions for me working with this initRD, because then you have a CPIO, like you have your initRD that is like in the beginning this uncompressed, I believe, maybe. Does it matter? Can it be compressed? I don't know, maybe not. Anyway, so you have in your beginning your CPIO archive, yeah, maybe uncompressed, and maybe that's relevant, maybe it's not. But so you have two CPIO archives combined, right? And the problem is that some of our tools, or similar to other Linux distributions, need to work with this initRD, and this combined initRD becomes super annoying also for you when you want to extract it, because the problem then is you can't just simply extract your initRD, because it's a bloody, like it's a double CPIO archive with only the bloody microcode in the beginning. So it's not, I mean, leave me in the comments below if you have amazing tools for that, but you would need a binwork or other binary separation tools of finding the second compressed. I mean, yeah, like checking the set standard compression header and stuff. My point is, the Linux kernel people even made this microcode update super annoying, in my opinion. I understand, so the old-fashioned, what is the problem with the old-fashioned way? The old-fashioned way was they were microcode tools, or now we have also in-kernel support for a decade, and normally you would trigger that during your boot. The problem with that is, and I mean, I fully understand the problem with that is that that is not atomic and too much stuff is already running, which is why this is the Linux kernel developer of Linus Torvalds himself and surrounding gang and family, sanctioned and blessed and modern way to load this very early when you don't have user space tasks running, or let alone many, maybe not even yet kernel tasks. So that is very, very, very early in the very early boot process of the Linux kernel. I totally understand where they are coming from. I would even argue it would actually have been better to make this the other way around, of not having this really annoying microcode payload in the beginning, but in the end, because then you could easier use user space tools for the extending of it, at least somewhat easier. But the problem with that is, of course, Linux kernel written in C, and C everything is annoying, and so I also understand they want it as easy as possible in the Linux kernel to implement in this glorified portable assembler preprocessor that is C, to simply check whether this is in CPIO archive very early in their very early boot process, to then potentially load this microcode. So long story short, you probably want to check your microcode. You maybe want to check whether you affected. Also, another data point of how complex, I mean, yeah, and no kidding, right? Billions of logic gates and stuff in your processor, whether it's Intel or AMD, Spectre, Meltdown, AVX state handling of it's like, I don't even want to know how their processor and microcode is architectured, that such kind of register rescheduling, shadow register tracking, I don't know what state handling stuff happens. There is one other workaround for this specific. I think somewhere they mentioned you can also, like, yeah, if you're running the latest BIOS, it's like, yeah, thank you very much. I'm not touching my BIOS anymore. It's broken enough. You can boot with some other parameter. Here, maybe this is even that. You see, other people can reproduce this, AMD Renoir SOC. And they don't have a microcode update, right? So for which there is no microcode update. It's like, yeah. Last but not least, so this is the stuff. It's not super bad, but it's also not super amazing, especially, unfortunately, in the case of Linux with this microcode handling. But the takeaway, multiple takeaways, In my opinion, CPUs are too complex, which is why I naturally for 20 years already prefer RISC, and why I previous videos have a lot of RISC stock here, and just restocked with Spark and PowerPC, the latest and greatest. And also processors need to become more simple, like RISC-V. And yes, even RISC-V gets more complex, but x86 obviously is too complex for even Intel and AMD to handle without Spectre Meltdown and other AVX state leaking bugs. And yeah, BIOS updates, microcodes suck big times. Intel and AMD need, and their partners like AMD, Gigabyte, Tyan, and Supermicro and stuff. The whole industry needs to become so much better, right? That major CPU microcode bugs are not really published, that even other renowned security researchers don't even easily find them, know about them. And then the microcode updates don't get to the customers. And most people, even IT, like which Windows administrator is reviewing microcode related stability bugs for their servers? I would even, if the NSA runs on x86, I would even be surprised if the NSA has all their servers updated to the latest microcode. And another takeaway for me is I, as annoying as it is, need to somehow adapt our Linux distribution to ship the microcode update. I need to test. Maybe I leave in the comments below. I will probably test if the Steam Deck is affected just for the fun of it. Maybe I even test if the Ryzen 1750X is affected, just to see if the latest and greatest Zen is affected. And I even, ironically, I even checked, because on the, with all the BIOS problems, previous videos on the Ryzen 7950X with a Gigabyte X670E BIOS, which was super buggy for months, like unstable buggy for months, that I had to use a 4 months or so old BIOS. I even checked whether the last BIOS updates the microcode, and it didn't. And I didn't even know about this bug, right? So now, yeah, I will check if maybe the 7000 series Ryzen is not affected, but 5000 series is, as you see. I hope you enjoyed this and learned something. As always, share, like, and subscribe. Leave in the comments below what you think. Support all my work on Patreon, GoFundMe, or this YouTube membership. And I hope you enjoyed this and learned something. Have a good day or night, and I hope to see you soon for the next fun stuff and security vulnerabilities to come.